So what is a surd? A surd is a square root that gives an irrational number, in which an irrational number is a number that cannot be written as a fraction and its decimal is forever going and non-repeating. So for instance, root 2 is a surd because root 2 cannot be written as a fraction, and if we write it as a decimal, we can see that it goes on forever and it's non-repeating. In contrast, root 4 is 2. And 2 is a whole number, so that tells us that root 4 is not a surd. And in GCSE maths, we tend to see questions that say keep it in its exact form. So that tells us that if we have a surd, we keep it in the surd format. So root 2, root 5, root 7. So here's a quick quiz for you to do. All I want you to do is to pause and identify whether these are surds or whether they are not surds. Okay, so let's see. We have root 3. Root 3 is a surd. Root 7 is a surd. Root 9 is not a surd because if you do the square root of 9, you get 3. And root 31 is a surd. So now we are going to talk about the rules when it comes to simplifying surds. So one thing you need to remember is if you do root A times by root B, that's the same thing as saying the square root of whatever A times B is. So for instance, if we needed to work out what root 5 times root 7 is, that's the same thing as saying the square root of 5 times 7, which is root 35, like so. Sometimes you might be asked to simplify a surds. And when it comes to simplifying surds, it is very important that you know your square numbers. So let's list out our square numbers. So you have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So let's say, for instance, we want to simplify root 108. So what we need to do is we need to look at our square numbers and look at our 108. Is any of these square numbers a factor of 108 that we can see? Well, I can see that 9 is a factor of 108. So to get 108, we would do 9, so root 9 times by root 12, like so. The square root of 9 is 3. So that will be 3 times by root 12. But now let's look at this root 12. Can we simplify this root 12? Yes, we can. Why do I say so? Because if we look at our square numbers at the top, we can see that 4 is a factor of 12. So let's simplify this root 12. So root 12, to get 12, we would do root 4 times by root 3. Because 4 times by 3 makes 12, and we just put that square root on top. Square root of 4 is 2, so that means root 12 simplified is 2 root 3. So now we're going to rewrite this again. So root 108 is equivalent to 3 times by root 12, which we've now written as 2 root 3. So 3 times by 2 root 3 is going to be 6 root 3. So that tells us that root 108 can be simplified as 6 root 3. Okay, so now we're going to look at adding and subtracting surds. So think about adding and subtracting surds as adding, like for instance, x plus x. X plus x simplifies to 2x. And why? Because we are collecting like terms, because x and x are like terms, so we can simplify them and add them together to get 2x. That's very similar to how we deal with surds. So for instance, if we have 3 root 2 plus 2 root 2, our answer would be 5 root 2. And why do we say that? Because 3 root 2 and 2 root 2 are like terms, because they've got the root 2 here. So all we need to do is just to do 3 add 2, which is 5, and then stick that root 2 at the end. However, we cannot collect terms, let's say 4 root 3 plus 7 root 5. And the reason why we can't do it is because they're not like terms. The roots are not the same. So this is in its simplest form. 4 root 3 plus 7 root 5. Just think about it like with your x's. You can't simplify x cubed plus x because they're not like terms. So we just write it as x cubed plus x. Now let's look at dividing surds. Dividing surds is actually very, very similar to multiplying surds. So for instance, if we have root a divided by root b, it's the same thing as saying the square root of whatever a divided by b is. So for instance, if we have root, let's say 42, divide by root 7, that's the same thing as saying 42 divided by 7 square rooted, which is root 6, like so. Okay, so now we're going to go on to rationalising the denominator. So what does rationalising the denominator mean in terms of surds? So for instance, let's say you have 6 root 3, and then we were asked to rationalise the denominator. What that means is we want to get rid of that surd at the bottom as our denominator. We want to get rid of it. We don't want a surd, we want a whole number. So in order to get rid of a surd, or in order to rationalise the denominator by getting rid of the surds, what we need to do is we need to times the top and the bottom by the surd itself. So we're going to times the top and the bottom by root 3. Root 3 times by itself will make 3, like that. And then 6 times by root 3 will make 6 root 3. Okay. However, sometimes we might get a question where we are asked to rationalise a surd that looks something like this. So in order to rationalise the surds, we need to get rid of the surd that's at the bottom, that's on our denominator. So in order to do that, we are going to multiply by itself, but this time I'm going to change the sign from minus to add. So we're going to multiply the top and bottom by 1 plus root 2. So if we do 1 minus root 2 times by 1 plus root 2, and if we expand using our FOIL method or whatever method you like to do when it comes to expanding double brackets, you would get 1 times 1, which is 1, 1 times root 2, which is positive root 2, minus root 2 times by positive 1, which is minus root 2, and then minus root 2 times by positive root 2, which you get as minus 2, like so. And then if we were to collect terms, 1 and minus 2 would be similar terms to collect. So 1 minus 2 is minus 1. And then plus root 2 minus root 2 will cancel out each other, because plus root 2 minus root 2 is essentially 0. So then we're left off with minus 1 at the bottom. Okay, so now let's do the top one. So we've got 1 plus root 8 times by 1 plus root 2. So we're going to expand the double brackets as we normally do. So 1 times 1 is 1. 1 times root 2 is positive root 2. 1 times root 8 times by 1 is positive root 8. And root 8 times by 2 is positive root 16. Okay. Root 16 is the same thing as saying 4. So that's 1 plus root 2 plus root 8 plus 4. 1 plus 4 is 5. So I left off with 5 plus root 2 plus root 8. So this root 8, we can actually simplify this root 8, because if we try and simplify root 8 up here, root 8, to get to root 8, that's the same thing as saying root 4 times by root 2. And the square root of 4 is 2. So that's the same thing as 2 times root 2. So root 8 can be written as 2 root 2. So let's do that. So we've got 5 plus root 2 plus 2 root 2. So now we can collect the terms here, because root 2 and 2 root 2 are like terms. Why? Because they've got that root 2, well, they've got the root 2 there. So root 2 plus 2 root 2 is going to be 3 root 2. So then we're left off with 5 plus 3 root 2 over minus 1. When you divide by minus 1, you're just changing the sign. So therefore, our final answer is going to be minus 5 minus 3 root 2. And that's it. Lovely.